occur independently. Natural selection occurred independently. Natural selection occurs independently. And so the individuals of each population became different from each other. They became different, right? Typically. And even if they were to mix again, they would not be able to reproduce with each other or interbreed. So that's how we apply the speciation question. Let's look at this worked example. So they say, this is on page 31 of your notes. So paging over to page 31. And I expect you now to answer these 4 marks, 4 minutes, 4 marks. So it says, the diagram below represents 2 types of shrimp. Each lives in shallow seas on opposite sides of a strip of land. Because the sea is shallow, they can't go over because they're living in this ocean, right? So there's a strip of land in between. So the strip of land represents what? What does the strip of land represent? A geographical barrier. In an investigation to determine, thank you, PD. So in an investigation to determine whether the 2 types of shrimp were from one species, scientists placed A and B shrimps together in a tank of seawater. So if they are the same species, so let's go back quickly. What makes 2 organisms belong to the same species? They must be able to interbreed and they must produce fertile offspring. So they must be able to interbreed and produce fertile offspring. So although the shrimps mated with their own types, the 2 types of shrimp did not mate with each other. Right? So they did not interbreed. The scientists repeated the investigation several times and obtained the same results each time. So give one conclusion the scientists came to after the investigation. What is the conclusion that you can now make? That the investigation was to determine whether the 2 types of shrimps were from this one species. So what would the conclusion be after the investigation was repeated? That the shrimp did not mate with each other and therefore, trying to see, why did the scientists repeat the investigation? Repeat, reliable. Easy mark, quick mark for you. Repeat means being reliable. So to ensure that the results were more reliable. Important also in our evolution is phylogenetic trees. Now this is a very simple phylogenetic tree. So a phylogenetic tree shows you the ancestry, or what's the most common reason of a group of descendants from branch point. Where the point branches, as we can see here, right, that is where the common ancestor lies. So this point is the common ancestor for A and B. This point over here would be the common ancestor for A, B, C and D, but not E. And this point would be the most recent common ancestor for all of these. So where the split occurs, that is the common ancestor of only of those ones attached to that branch. Right? So this is not a common ancestor to C, D or E. Okay? So phylogenetic trees shows us which are the most common ancestor of a certain group of organisms, or certain species of organisms. Now we get to humans and their ancestry and apes. So there are certain similarities and differences that we share with our African ape counterparts, right? And you will find in your textbooks. I don't have time right now because I see it's already almost 2:15. So I'm going to skip this, and you can look at it like upper limbs, opposable thumbs, your brain, vision, the number of offspring that we produce, the number of differences between African apes and humans, right? If you look at the differences in terms of our brow ridges, our flat face, prognathus is a slope of the face, right? Our brain sizes, which are different, the cranial ridges, prognathus. And I want to get to a, right, and there we see at the bottom of the skulls, you need to be able to do this at the bottom of the skulls to show the differences in your teeth, large or small canines, the position, this is very important, the position of the foramen magnum, whether it's at the back of the skull or more in a more forward position, which gives rise to a condition called bipedalism, right? The palate, this is your palate, the palate shape, the size of the jaw, one being large and the other also quadrupeds have C shapes, the pelvic girdles are also different, right? Humans have broader, narrow, short, wide, long and narrow, right? And also the large, humans have larger brains than the ape counterparts. And then cultural differences would be how we communicate and the tools that we use. Now I'm going a little bit fast, but I want to get to the question so that you know how to answer them. So on page 26, right, they have given us a diagram. When you are given a diagram and you need to identify something, or you need to explain or substantiate your answer, it has to appear on the diagram. If it does not appear on the diagram, you cannot give it as reason. I cannot see the pelvis here, I cannot see the spine or the vertebral column. I cannot see the arms or the opposable thumbs. So I cannot use that as evidence. I can only use what I see in the diagram. Okay? So, first of all, it says label part X and the type of teeth at Y. Right. So what appears at X here? What is this? It is the foramen magnum. And the teeth here is our canines. Right? So the teeth are the canines. Now, explain the significance. Now, the word significance also means the importance. Why is it, what does it do if the location of the foramen magnum changes? Right? What's the importance thereof? Right? So, thank you, Dawn and BD, for your answers. So, what's the importance of the shifting of the foramen magnum from a backward position to a forward position? Right? That's what this question is asking, to explain. So, it's not a one-word question. Right? More forward position allows for bipedalism to occur. Absolutely correct, right? So the foramen magnum is located in a more forward position, allowing the skull, showing that the organism is bipedal. So you will get 2 marks though, because remember it's 3 marks. Why? How is this possible? Because it allows the vertebral column to extend vertically. Now, Dawn gave me the first part, gave us the first part of the answer, right? But it's 3 marks. Why? Because she did not elaborate why it occurs, right? So, be careful. So, you normally lose out that one little mark something because you've not fully or completely answered the question. It says explain the significance, right? So what is the significance? That the forward position allows for bipedalism, yes. Why does it allow for bipedalism? Because it allows the vertebral column or spine to extend vertically from the base of the skull, which allows the balance of the body weight in an upright walking position. Okay? Be very mindful that you've answered it as fully as possible. Let's go on. Which skulls A, B or C belong to the Australopithecines? Right? So we've got Australopithecines as being, some answers are B, and the quadrupedal primate. Which one is the quadrupedal primate? Would be A. Thank you very much. Right? So they have B as the Australopithecine and the quadrupedal primate as being A. Explain how changes in the skull from B to C could indicate a change in intelligence. So explain how changes in the skull from B to C, right? The skull from B here. So what about the skull brings about intelligence? What do we notice here from B to C? What happens to the skull? The cranium becomes larger, therefore it can house. Now, if you're just going to write larger brain, let's see. Do you see these 3 marks? Right? So if you just write large brain, you will only get 1 mark. But what allows for a larger brain to occur? There is an increase in cranium size from B to C. Right? TM, brilliant answer. Right? But now you have to quantify to say that there is a larger brain. So the first person would get 1 mark and TM would get 2 marks, but TM did not say that it houses a larger brain, therefore there is greater intelligence. Okay? Fully answer the question, otherwise you miss out these 1 mark here and there, and if you add it up at the end of the day, it can be quite a bit. Tabulate 2 observable differences. Remember I said, look at it, it has to be observable. That's what I can see in the picture, other than those mentioned in 3.4.2 and 3.4.4. So we can't mention the cranium and we can't mention the foramen magnum between skulls B and C. So what do I notice? I can't mention the cranium and I can't mention the foramen magnum. What can I mention? I can mention the gently curved jaw as compared to the rectangular jaw, right? Sorry. I can mention, the answer was too long, right? Canines, what else can we mention? This I can mention a well-developed chin, because there I can see a chin and there I can see a chin. Right? So we can see the chin over there and we can see there's a definite chin over there. Right. Thank you, Batala. Right. So it's observable differences. What is this? What is this? Flat face and sloping face, right? Well-developed eyebrow ridges, good. So we can see there is an eyebrow ridge, right? Thank you very much. So I'm glad to see that a lot of you are actually looking and listening and noticing that observable means that I must be able to point it out on my diagram. Let's move to page 27. We have 8 minutes left. So I'm going to move a little bit faster. I'm sorry that we didn't get to reproduction today. So let's look at page 27. The diagram below shows a world map indicating 4 sites where fossils represented 2 different genera have been found. Genus A was found in 3 sites, 1, 2, 3, in 2, site 3 and site 4, and B only in 1 site, which is site here. Okay. So the age of the fossils was determined using radiometric dating. So which one do you think represents your Australopithecus? Okay, TM says B. Anybody else? You are absolutely right. Why? Because we know that Australopithecines, according to the out of Africa hypothesis, they are only found in Africa, right? And nowhere else in the world. So therefore, right, the answer is B. Second question, has more prognathous skull? Let's look at the skull. What do we see here? Which one is more prognathous? It would be B again. Has smaller canines. Now it's very difficult to see the canines, but we know which one would have smaller canines. Which one would have smaller canines? Hanane, Hananang. Yes, Basir is correct. Right, it would be A, and is more closely related to Homo sapiens. Which one? Would this one be more closely related to Homo sapiens or that one? It would be A. Well done, Fez and Salome. Right, so it is more closely related to Homo sapiens. Name 2 examples of fossils of genus B. So it's examples of genus B found at site 1 in South Africa. So we're not talking about the rest of Africa, we're only talking about South Africa. So, Little correct, Karabo correct. Is Adi found in South Africa? Mrs. Place is correct. Australopithecus sediba is correct. Right, we've got another Mrs. Place. So yes, excellent. We also have Handyman is not an Australopithecus. Right, does not belong to Australopithecus. Handyman is Homo habilis. Be very careful. You have to be able to identify the skulls, you need to be able to identify the genus and species names, right? And which genera they belong to. So it was the genus B, which is your Australopithecines, it can't be RD because RD is Ardipithecus, and it can't be Homo habilis because Homo habilis belongs to the Homo species, okay? The genus Homo, and not Australopithecus. At which site 1 to 4 were the youngest fossils found? At site 4. Thank you, Dawn. Right, so Dawn says, and Batala is correct. It is at site 4. Other than fossil evidence, what other evidence can be used to support the out of Africa hypothesis? What other evidence can be used besides fossils? Remember we spoke about genetic, yes, brilliant. What others? Okay, so we can use genetic, could be, you can even name it, mitochondrial DNA, mtDNA, genetic evidence, the Y chromosomes, and cultural evidence we use to support out of Africa hypothesis. Well done. Carrying on. Now this is a question that I really want to do, because here we are given a graph, but we are going to be asked brain sizes, and you have to be able to read things like this. So it says scientists estimate the brain size of Australopithecus, Homo habilis, and Homo erectus and Homo sapiens by using the cranial capacity of fossil specimens. They then compared the results to the time that the hominid existed on Earth. The graph below represents the range. I don't understand, Batala. They then compared the results to the time that each hominid existed on Earth. The graph below represents the range of brain size, the time period that hominids existed according to fossil evidence. And then they had the results. So according to the graph, now look at my graph, I've got brain size and I've got time, but it's millions of years ago. Squares are Australopithecus. This is Homo habilis. Homo erectus is the circle, and Homo sapiens are there. So in time we can see that Australopithecus was first, then we had Homo habilis, then we had erectus, and then we had Homo sapiens. And we looked at it in terms of brain size. So when did the first Australopithecus appear? So look at the time here. We have to read it from the graph. So this is 3 million years to 4. So this would be, what line is this? Is it on 3? Just be careful. Is this line on 3? It is. Okay, we've got 19, we've got 4.9. Now, when we read millions, this is 0. And so I'm reading this way. And it's increasing this way. So 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, and 4. Right? So therefore, it is 3.1. Okay? Which of the species shows the greatest variation in brain size? Can you see this is the biggest? So it's Homo sapiens. Unfortunately, I see time is up. If you allow me just to give you the answers. So this is also basically looking at brain sizes. Largest would be here and smallest would be there. So smallest of Homo sapiens is there, and largest of Australopithecus would be 500. Can you see? And state 2 types of evidence. Okay. So thank you very much. we will be doing reproduction when we do our classes on a Tuesday. Then we will continue with this lesson before we can start with the new work for the new term. I thank you. I appreciate all the input I got from all the learners.